So data science. It's a term you hear thrown around all the time, right? But what does it actually mean? Well, in this explainer, we're going to cut right through the hype. We'll break down how it works and, maybe more importantly, how it's already shaping your world. I'm talking about the apps on your phone, even the future of our cities. So yeah, let's dive in.
Okay, first things first, let's set the scene. Think about this. Every single time you click or post or search for something online, you're leaving behind a little digital footprint. And all of those little footprints, they really add up. So that brings us to this big question. Are we really living in a data explosion? Oh yeah, the answer is a huge, resounding yes. And get this is wild. In just the last 2 years, we've created more data than in all of human history combined. I mean, just think about that for a second. With the explosion of social media, all our connected devices, we are just generating an absolutely unbelievable amount of information every single second. You know, we're not talking about gigabytes or even terabytes anymore. We have officially entered what's called the zettabyte age. And to give you some scale, a single zettabyte, that's a trillion gigabytes. So the real problem today isn't that we don't have enough data. Oh no, it's that we're basically drowning in it and we're just trying to find the important stuff, the signal, in all that noise.
So where does all this data even come from? Well, it's pretty much everywhere. You've got the obvious stuff, right? Like your social media posts, your emails. But then there's all the less obvious things. I'm talking about server logs that track everything you do on a website, all those videos and audio files, readings from Internet of Things sensors in smart homes or cities. And of course, you've got the huge, massive databases that companies and organizations have been building up for decades. Okay, so we have this absolute flood of information. How in the world do we find any meaning in all that noise? Well, that is the exact problem data science was born to solve. It's a field that's all about cutting through the chaos, taking all that raw, messy data and turning it into something clear, something you can actually use, actionable knowledge.
When you get right down to it, data science is really a mix of different skills. It's about grabbing data from all those sources we just talked about, then you got to clean it up, process it, and then you analyze it, all to find useful tidbits of information that help people and, businesses make much smarter decisions. And the real power? It's all in the results. With data science, companies can do more than just see what already happened. They can actually start to predict future trends. It can spot those super subtle patterns that might point to credit card fraud, or it can make sure the right ad gets to the right person. And ultimately, this stuff informs the huge strategic decisions that really shape our whole economy.
All right, to really get a handle on data science, we first have to understand its raw ingredients, the data itself. And believe me, it comes in a few different flavors, and each one has its own set of challenges.
First up, we've got structured data. This is the nice, neat, tidy stuff. The easiest way to think about it is like a perfectly organized spreadsheet or an old-school filing cabinet. Everything has a place, it follows a preset format or schema, which makes it pretty easy to work with.
Here's a perfect example, a simple bank database. See how it's broken down? You have a customer table with specific fields like ID and name, an account table, a transaction table. Everything has its own little box. It's super organized. This is pretty much the foundation of most traditional data systems.
Okay, our next flavor is semi-structured data. And this is kind of the middle ground. It's not as rigid and strict as a database, but it's not total chaos either. It uses things like tags or keys to create some organization, to create a hierarchy. You'd see this in something like an XML file or even in some server logs. And then there's the big one, unstructured data. This is the wild stuff. It's information that has absolutely no predefined model. We're talking about the text inside an email, the actual content of a video file, a photo you took, a social media post. And here's the kicker. This is the type of data that makes up the vast, vast majority of information being created today.
And last but not least, we've got data streams. This is exactly what it sounds like. Data that's being generated continuously, in a constant flow. Just imagine weather sensors that are always reporting the temperature and humidity, or data coming off a smart device in your home. The big challenge here is that this data is often huge, and you have to process it pretty much in real time.
Okay, so you've got all this data, structured, unstructured, you name it. Now what? What do you actually do with it? Well, let's take a look at the Analyst Toolkit. Think of it as a journey where you ask smarter and smarter questions as you go. This whole journey of analysis really boils down to 4 main steps, and each one builds on the one before it. You start with descriptive analysis, which just asks what happened. Then you move to exploratory, which asks, okay, why did it happen? After that, there's inferential analysis to make bigger conclusions, and finally, predictive analysis to guess what's going to happen next. For this intro, we're just going to focus on those first 2 really crucial steps.
So let's start at the beginning. Step 1, descriptive analysis. This is all about summarizing the absolute basics of your data. You're not trying to draw any big conclusions here. You're just trying to create a clear, simple picture of what you've got. And you can see exactly how this works with this simple example. We've got data for 10 students. A descriptive analysis just counts what's there. So the table tells us we have 5 females and 5 males. Boom, a 50-50 split. It's simple, it's clear, and it's the foundation for everything else we're going to do. And a huge part of describing data is visualizing it. So we take that simple table we just saw and turn it into something like this pie chart. It's the exact same information, right? 50-50 split. But it's presented in a way our brains can understand in like half a second. That's the real power of a good summary. All right, so we've described our data. Now let's move on to the next step and see how this all builds. We're going to explore it. This is where we stop just counting things and we start digging around, looking for potential patterns, for connections, for relationships between different pieces of the data.
This box plot is a perfect example of what I'm talking about. See, instead of just counting males and females, now we're comparing their heights. The plot shows us the whole range of heights for each gender, and you can see right away, at least in this little sample, that the heights for males tend to be greater than for females. Now, we're not proving anything yet, but we've explored the data and we found a potential relationship that might be worth looking into more.
So we've talked about different data types, the first couple steps of analysis, but I know this can all feel a little bit abstract. So where does the stuff actually show up? Let's bring it back down to earth and look at how data science is a part of your everyday life.
I mean it. Data science is literally everywhere. It's the reason your traffic app can find the fastest route. It's analyzing real-time data streams. It's behind all those personalized ads you see online. It helps companies figure out the best shipping routes to get you your packages cheaper and faster. But it's also used for huge things, like helping to shape public health policies, making our cities smarter by managing energy and water, and even studying the environmental impact of major construction projects. When it comes down to it, data science gives us a totally new way to see the world. It gives us the tools to stop drowning in information and start making smart, evidence-based decisions. So I guess the real question it leaves us with is a big one. Now that we have this incredible power to ask questions of our data, what are the most important questions we should be asking next?